These three things that I'm about to share with you in this video changed the way I approach building AI agents for myself and my clients. And whether you are a business owner trying to implement AI or somebody who's trying to sell AI agents to other businesses, I'm pretty sure it will change yours as well. Now that AI is trending everywhere, it seems like everyone is talking about the upside, how they're using AI to save time and automate their work with all sorts of agents like content creation agents, lead generation agents, SEO agents, all of these different agents, which is great, but nobody seems to address the downside of building agents and the pains. An AI agent is fundamentally software, and software can go down at any moment, as I'm sure you know, especially if it's not built and implemented correctly. It could cause extra headache for you and your business. You might find yourself spending countless hours trying to get it working. And that's why in this video, I'll show you exactly how to avoid that by showing you three things that I learned only after building hundreds of workflows within N8N, getting a top-rated Upwork profile for selling AI agents and automation to other businesses for all sorts of tasks, so that you don't have to make the same mistakes that I made before this. We'll be covering how to build reusable AI agents to save you time, how to make them work effectively as one unit, as well as how to avoid the pitfalls and keep your business ops going smoothly in case anything does go wrong. With that being said, let's jump straight into it. And by the way, if this seems a bit advanced for you, then check out my YouTube channel because I've got a full 4-hour masterclass to help you grasp the basics of N8N, AI agents, and automation. Check that one out first. So the first thing we're going to talk about today is building your agents in a modular, easy to reuse fashion. What we want to be doing is building specialized agents. Andrew NG, who you probably have heard of, is massive in the AI space and done a ton of research around this, suggests that specialized AI agents in your agentic workflows are 63% more effective than a single prompting large prompt approach with lots of different tools attached. I'm going to walk you through the logic of why I think that works much better now. Let's run through a scenario here where we're building out our first agent. So we have this, what we're calling a master agent here, and all we want it to do is take one action, schedule event. So we have a prompt. The prompt is really clear. You must schedule an event. You receive details. You schedule an event. We then start building on that agent. So actually we've decided it's going to be a full calendar scheduling agent. So now we've got this kind of convoluted but still focused master calendar agent. Okay, now you're going to schedule events, you're going to update events, and you're going to delete events. Great. The prompt is still really clear. It's a calendar scheduling agent. Now the client asks us to expand the functionality of the agent. So they want it to also respond to their emails. So now we've got, as you can see, getting slightly more complicated. We've got a master agent, which is in control of our calendar and our email agent. So it can delete events, schedule, update events, but now we've also got 5 other functionalities and probably more associated with emails. So we can reply to a thread, label emails, draft emails, delete emails, and send emails. So the prompt is starting to become a little less clear now because our role of our agent is actually shifting. So we have to, in the prompt, reiterate that it's both a calendar agent and an email agent, but also routing the queries to the correct tools. We go a step further and the client's really happy with what we've done. The agent's working effectively, but now they've asked, okay, how can we incorporate our sales tools and our financial tools as well? So you can see where this is going, but now we've got a few more use cases, and this is still a simplified view. So we've now got this master, calendar, email, sales, and financial agent. So everything we could do before, we could still do, but now we can reach out to our leads, we can track our leads, we can do financial forecasts, and we're also monitoring invoices. Now you can see that when we start to write the prompt for this agent, it's starting to get confusing what the actual role of this agent is. It's one master agent who has all of these tools that it has access to. So when we start to write the prompt or adapt the old prompt for this all-encompassing agent, you can see that the role is becoming less clear. There actually have 4 different roles here: a calendar, email, sales, and financial agent. And each of those roles might have independent tasks or independent tools at which they operate. So that not only is the prompt getting significantly longer and harder to maintain, it also probably is not giving us as good a quality of output, because it's got so many tools to comprehend and actually work with, that it's probably making more mistakes than a focused agent that we had before around calendar and email. And then we've got to ask ourselves, what would you do at this point if this was a real team of employees in your business? Now, hopefully it makes sense here that what you do is actually split those roles and responsibilities. And that's the same way we think about the architecture for these AI agents and these master agents and how they work together. So the way I think about it is that we've got this incoming request on the left-hand side. We have the equivalent to our leadership team, which is actually just routing. So they are solely responsible for understanding what the query is about and the context that's been received, refining that, and passing those details onto the relevant team, which in this case is our head ofs or our managers. So we might have ops team, a sales team, finance team, and a customer team. And each of these teams has a separate role and a separate scope with a separate instructions and actually different resources that it's able to leverage or different tools that it's able to leverage. Within the ops team, you can see that then we have a bunch of employees. So in this case, it might be equivalent to the ops team having several functions, one to manage our calendar and one to manage our email. And even within that, those employees have lots of different tools to complete their tasks. So that might be the ability to create events, delete events, and update events. But we've got one employee, or one LLM in this case, managing our calendar and one managing our email, with the sole function to get that job right. So the exact same way in which you'd set up a company structure, you should be thinking about your AI agents and how to keep them really focused on individual tasks. So what does that look like from a prompt point of view and an inputs and outputs? So we effectively have this master routing agent, which receives all requests, no matter what they are, from various different triggers. So we can set up multiple trigger types like a chat, email, Google Drive files, and they are solely responsible for directing to the appropriate team the context and the request. So they might retrieve some context, like some company knowledge from a database. They might refine the query to make it more specific, but they're ultimately passing a clear context to the team specialist, which is also an agent or a set of agents, for example, the ops team, that have a completely different task of how to work out what are the best tools to execute the requests we've received and how do we translate that into actions. So this team specialist is in charge of finding out which part of the execution layer is best positioned to execute this request and what actions do they need to take. So in practice, that might be the email LLM handles emails and they need to reply to thread in this instance. So that will be passing the actions to that specific tool as part of the execution layer. So far we've got a routing agent that directs all queries, a team specialist, which is several agents that represent different functions of a business. And both of these are agents because they're able to think about and iterate their approach on where to route the queries to. We then have the lower level layer, which was our employees in this case, which is this execution layer. The execution layer is actually just an LLM. It's not an agent because we're not iterating on the approach. The team specialist decides what action needs to be taken. The execution layer, which is an LLM, just executes. So they understand from the inputs what actions to take, what tools to use. They must just execute on that action. And then finally, the execution tools, of which their execution layer is using, just outputs for us success or failure. And all of that feeds back up the chain to the routing agent, which ultimately sends our request or response to the request back to the user. So as I'm sure you can see, there are multiple ways in which we can lay out the architecture of our agentic workflows and agents, but this is the one that's proven most effective for use cases with my clients. And this is what it looks like in practice. So we'll go back to our N8N flow, and you can see how this looks exactly when we're actually using it. So in here, we've got our gatekeeper agent, which we defined as our routing agent, and it has access to this pre-processing stage, which is where it can refine the tool or pull additional context from things like web research or the company knowledge base. Its sole responsibility is to route the different queries to the different teams. Those teams themselves are agents, so we'll go into the ops team as an example. Set up in a very similar manner, it receives the query in the context from our routing agent. It then has a sole responsibility as an operations agent to schedule calendar events and email operations by utilizing the execution tools it has available. So again, we might go through some pre-processing where it adds some context like web research or company data if it needs it. However, its main function is to actually work out whether the request that it's received should be going to the calendar tool or the email tool, or neither. And then inside the calendar tool, you can see this is just purely an execution layer. So this calendar execution layer receives the actions it needs to take and needs to determine the tools that it needs to use for that. So it's connected to all of our different event types here, like creating, updating, deleting, and getting events. But its sole purpose is to execute the request from the operations team that it receives. So you can see down the chain how they become more and more specialized. And what this leads to is a higher success rate because each query is going through almost like a validation stage before it hits the correct tools. And only when it reaches the execution layer does it have access to the right tools to complete the function. And once it's completed that, it passes it back through the operations agent and back to the gatekeeper agent, which then sets the response and sends to the user. This is one of the best ways I've found to structure my different agents, in particular when you've got lots of different agent teams working together. So we've set up our agents in a modular fashion, and they're now starting to work really well together. We think we've reached the MVP version for our client, so we hand it off. At this stage, it's where I suggest externalizing the prompts. So when you have a prompt in N8N, it's stored within the agent itself. The user prompt will come inside the text window here. So here you can just see we're passing the query input. And then the system prompt will come down here, which makes it really easy when you want to test and update. You just come in here, add a few lines of whatever instructions you want to add. Super simple. There's 3 key reasons why you might want to take this prompt and store it elsewhere. The first is that you might be working with non-technical teams that don't actually want to come in to N8N or don't know how and update the prompt directly. The second reason is that you're probably updating your prompts regularly. If you're using these AI agents, you understand that the models are changing, the technology is evolving, and the prompts therefore change on the back of that. So if you're updating this regularly, you're going to have to come into every single agent you've built on your client environments or on your own and update the prompts in multiple places. The third reason is off the back of that, which is actually you want a good prompt to be completely reusable. You don't want to be rewriting a prompt from scratch every time. And actually you might have multiple parts of this which are reused across your flows. And if you want to update that, you just want to do that in one place. So let's show you now how to externalize your prompt in something like Airtable and pull it in dynamically. So you don't need to worry about updating it everywhere. You just update it in one place. So we're going to copy the prompt here and we're going to come out. And what we're going to do is go to an Airtable. And I've pre-set up this Airtable. It's available in the school community if you want to grab it. But for each agent we set up, I've got a demonstration here. We'd have a routing agent, for example. And what we do is actually store the prompt in this field directly. So we know it's a system prompt here. And then the user prompt, in this case, we're leaving blank. What that means is that we can give access to this base to our clients if they are updating the prompt directly to see the results, or we can just store this for ourselves and come back in here when we want to change the prompts. So we'll go back into our gatekeeper or routing agent, and what we're going to do is hit tab and open up the Airtable node, and we are going to search records, and that will help us get back the record that we want to retrieve. If all of this is new to you, then I definitely recommend checking out my 4-hour masterclass on N8N. It covers all the fundamentals that you'd need to know to build out your own AI agents and automation workflows. But assuming you have done that, we're going to come in here and fill out all the fields. So we'll call this get prompt. And what we're going to do is just choose our base, which is in here is our scrapes.ai tutorials. And then we're going to choose a table from the list, which was our agent prompts. We're not going to filter by any fields because we want to return all the prompts. I'm just going to test this step and pull all the records from there. So you can see that dynamically we've pulled from our routing agent the system prompts directly. So all we need to do now is put it between our triggers. So we've connected it up to our first trigger. We will disconnect that and connect it here. Pull that all across. So you can see that both triggers now feed into our get prompt. So we've connected that all up. So inside our agent itself, we can actually now completely replace the system message. And from our previous nodes get prompt, you can see that our system prompt can be pulled in directly here, and it's referenced by json.systemPrompt. And all we're going to do here is what we normally do, which is reference the node name in particular, get prompt.item.json.systemPrompt. And we're just going to change item to first, because then that will reference the first result we get for our system prompt. If you have multiple agent prompts stored in this table, then we're going to need a slightly different approach. So instead of getting the prompt directly without a filter, what we might choose to do is say if the field agent is equal to routing agent, and then it will only return that one prompt, and test that out. That now only returns the routing agent prompt. So we just have one item pulling through there. And you can see now inside our system message, we are pulling, if we open this up dynamically, the exact prompt from Airtable through our system message. Now there's a couple of things to note here. The first is you can see that it's passed through on one of the constraints. Today's date is now in the curly braces, which hasn't updated as a dynamic value. So what we will just do is add a constraint here, and we'll go back to our Airtable and actually just remove the today's date is now from the constraints. And then if you have any other constraints, they'll stay in there. And you can see our new constraint is at the bottom here. Today's date is, and then it actually gives the actual date. So if you've got any dynamic variables, still include them here directly, but it means that those won't ever be updated. But if you need to update the prompt itself, it can be updated in our system prompt here. So that is the second thing that you should definitely do once you've got to the point where you've tested and it's now ready for the first version to go live. You should externalize your prompts, because it will save you having to edit prompts all the time in multiple places. And you can just instead edit inside your chosen database. In this case, Airtable, it could be Google Sheets, it could be a Google Doc, and just pull that dynamically back into your agents. We could do the same here in our operations agent and actually pull that prompt in dynamically once it's at the point where it's production ready. And that will save you a lot of time, as well as allowing your clients to go in and edit it directly without having to visit N8N, for example. Now, the third thing that's absolutely crucial, a 3-layer error handling procedure. So we've first got what we call a preventative measure. So when we're preventing errors from happening, we're actually just validating that the data that's input is correct and as it should be. So for example, inside the agent team operations. So we've got the operations agent here. We've got an executed by our gatekeeper or routing agent trigger. So that will activate this flow. But we don't actually want it to activate if it's passing the wrong instructions. So inside our executed trigger, we have different input data modes. So we could choose to accept all incoming data, which means actually we could accept everything. And if it's incorrect, we're going to cause a failure in our LLM or later on. Or we could define using the fields below or define using a JSON example exactly what it should be receiving and choose to fail at that point instead of passing it through to later in the stage and risk it getting through to our production environment. So for example here, we're actually just receiving a query from our routing agent, which is the original user query, and also the context. So maybe that's additional company knowledge, some web research, anything that's relevant for this operations agent in the flows that it's going to execute are retrieved through here. But we've also specified the data types that they should be strings. So if we receive anything different or any additional fields, it will actually reject at this point. So that's a preventative measure to stop it running. The second measure we should use is corrective. Inside the ops agent or any LLM or any node inside NAN, you have this retry on fail option. So if we click retry on fail, we get to select the maximum number of tries it retries and the wait between tries. So if this fails the first time, which it sometimes will, for example, OpenAI might go down, or there could be a server issue with OpenRouter, what this would do is just force it to retry 3 times, waiting a second between each retry. So we can just leave these as standard, 3 and 1000, but that is a corrective measure that will help reduce the number of issues or flagged problems that come up when you're running these workflows or agents. The third one is probably the most powerful, which is assigning fallback agents to these tasks. So if we think about the dependencies that this ops agent has, it has the data coming in, which we're validating, which is the first measure. It has whether it connects to the server correctly, is a second measure. But in production use cases, we always want a fallback. If we think about the dependencies here, we've got this operations agent that's actually acting through OpenRouter. So OpenRouter is a dependency, but it's also connected to a model, which is GPT-4o, which is provided by OpenAI. So there's 2 dependencies in there that we can try and counteract here. So what we can do inside the settings is on error, continue using our error output, and that will give us an additional output branch that we can follow in the case that one of these components fails, which at some point it will. Your API key could run out of credits. That is also another example of a dependency there. So ideally what you want to do is replace all of the things that we've set are dependencies here with a fallback method. So we will copy paste the ops agent here, and we'll bring it up here as a fallback. We will connect that error workflow to this. And instead of connecting this to OpenRouter, what we might choose is to actually connect it directly through OpenAI. But then you see we've also got the dependency that maybe the model will fail, or maybe OpenAI is down. So a better solution as a fallback would probably be to choose a completely different provider, like Anthropic, and connect to a completely different model. So this first option has our ops agent connected to OpenRouter and an OpenAI model. But actually, if all of that fails, we will just pass that directly to our fallback ops agent, which we'll name fallback agent, which has exactly the same prompt, but is connected not to OpenRouter anymore. So we've removed that dependency, and also not to OpenAI. It's through Anthropic. So you have to use a different model. We'd then connect it up to all of the appropriate memory and tools. So it has exactly the same functionality in case we go down that route. Now it can start to look a bit messy, but in a production environment, this is really critical. And at this point, if both of those have failed, you can set up more fallbacks, but you probably just want it to send you an error message. So we'll put in the error there. But if it's successful, it should also follow the same path of setting the response here. So those are the 3 layers that you can implement today: the preventative, the corrective, and the fallback, that will help make sure that your clients' workflows continue to run even if there are issues with one of our dependencies there. So to sum up, we've learned a great style of architecting different AI agents and how to make them work effectively as one. We've learned how to externalize our prompts and take them to a different system to update only in one place where our clients can update there too. And finally, we've learned the 3 layers of failure handling to ensure that these workflows continue to run even if a dependency fails. So I hope that those tips are going to be really helpful in implementing in your business. And thanks so much for watching.